Okay. All right. So let me just go. There is like the big data, the Hadoop, these technologies may come and go, but the science behind data things is standing for a long time. So that's something interesting that we get from media. Also, if you look at in academia, right? NSF just announced like a couple of weeks back a lot of funding for this data science projects. And NYU, have you really looked at the NYU data science initiative here? No. So if not, just go to the page. It's really good. They have a very good data science curricula sorted out there. So NYU has invested lots of initiatives in data science, and we had data science conference just a couple of months back here in downtown, along with here the medical center, and you can see that NSF. The UCSF was awarded 1.5 million, right? I mean, there are so many of these things that's coming up, and I think Obama also initiated some big big data initiative. And so we can, if you think that media is hype, then the research centers are also gearing up for the big data, and that is a strong reason that we will be going over to see why that is the case. The demand is likely to outpace supply, right? I mean, there's lots of data being generated, as you know. It's 50 times going to be more data in 2020, and there's going to be a shortage of 140,000 to 200,000 people here in the US. And so, and the job prospects are extremely good for this data science. About 94% of the US graduates have found jobs so far, pursuing data science. And if you look at the public opinion, it's almost more than 75% of the people think that the data science, there'll be a huge demand for the data science, right? It's one of the top job in the US. And okay. So it's one of the top jobs in the US. And when we look at the predicted job market, it's about 11%, 4% more than any other industry that's growing so far. So it's in a very high demand now. And it's also extremely well-paid career. Like if you think the average salary for data scientists, it's the salary they say here, it's made up of several other things. I mean, this could be for a very experienced data scientist, but in general, it's a six-figure salary that we have so far in San Francisco. We have about 140 is the average for these data scientists. So that's the kind of a thing that we are talking about here when we talk about data science. It's a very big industry that's in huge demand. And so why is data science so popular? Why data science? Why should we have it? Right. The first reason for it is the drastic reduction in storage costs. Right. The technology. So this is the graph of how the hard drive cost per gigabyte in US dollars fell down over the years. In 1980, we have about $1 million for a gigabyte. That was the cost, and it's now 0.3 cents. I mean, it's now 3 cents, and that's the drastic reduction in the storage cost that we have, and that's due to technology, right? I mean, they're improving lots and lots of things in hard drives. So that's one of the key reasons why data science is data science is so popular today. And also the technology is also reduction in computing cost. Who knows Moore's law here? Good. So it's the number of transistors, right, in the chip. It reduces. It increases double every year, right? I mean, that was Moore's law, and he predicted in 1965. And this trend will be continuing for years. So it stood up for almost 50 years now. And although it's about ending right now, because the more transistors that you cram into the processor, the more heat you generate. And so we have to find some solutions for that. So it's kind of ending almost now. And also there's quantum computing that's coming up. But in general, the computing cost went drastically. And if you look at the graph there on your left-hand corner, you'll see that that's the computing cost. It's per 1 million transistors and the storage cost. So they went drastically down. And these are the two key technological technological explosion that led to this genome explosion of genomics. Actually, this next-gen sequencing, right? I mean, we store lots of data, we compute lots of data, and it's a high-speed camera at the end of the day, right? And so the cost per genome has gone down drastically. So it was about really high in the 2007 to 2017. We see it has come down less than $1,000. There's a new 10 HiSeq 10, right? I mean, this is that can do the genome for less than $1,000. And more data as we generate, we have also started the analysis of genomes that requires additional storage and interpretation. And so obviously we need there is a big need in data science. And in general, big data has immense value, right? The strategies for determining which is an effective way to reach the market, right? So almost 100 there are lots of thought leaders. They make most decision out of data. I mean, Google, Amazon, for instance, every day you buy something, it recommends you based on machine learning algorithms, big data, again, and most of the leaders, the industrial leaders, are likely to have a formal, education in data science, and also they almost make decisions completely based on predictive analytic capabilities. Like, I mean, there are so many algorithms that can perform predictive analytics. Most of it could be statistical and machine learning nowadays that we can do lots of predictive analytics, and so big data has lots of value. That's one of the key reasons why data science is flourishing, right? And also rising expectations. We need our computers, we need our mobile systems to be smart. They want to behave like humans. I mean, we want an adaptive learning. It has to understand every time that we do something, that it has to learn as the information changes. It has to be interactive and contextual, right? It has to understand the context upon which things operate, and then do that. There's a web 4.0, the context-based web, and things like that, right? And so it also requires processing large data sets of different types, right? I mean, so many data comes in numerous forms, and so we need to process all of them together and then make an interpretation out of it. So these are some of the challenges. That's why we really need that. And also the next frontier, if you look at it, the Internet of Things. How many of you have heard of these Internet of Things? Right? I mean, it's like an interconnected world now, right? Your mobile can automatically sync with your computer, and so this is what the next frontier is. Like, it's an integration. So almost 59% of the thermostats are connected to the internet now. We have smartphones, and also we have the vision, the camera vision that automatically updates. So many other things like the security systems. And so if you look at 38% of the social life, right? I mean, it runs on the internet. And there is also an ongoing, I mean, when it comes to medical, right? I mean, that's a huge thing. I mean, we have the Fitbits and so many other things that are connected together. So we are all converging towards some grand union of things here. And so if you look at the projection in 2020s, we have 4 billion people who are connected with lots of opportunities. The more the connection, there is a tremendous amount of opportunity for revenue. And also the apps, there is another apps market there, and lots of embedded and intelligent systems out there. So about 2020, we have 50 trillion gigabytes of data to be analyzed. So it's lots and lots of potential there, right? And when it comes to biomedical data sciences, Internet of Things, right? It could be restricted to just medical. If you look at things from the medical technology alone, there are lots of potential there. Like, people want their health to be monitored, and the physicians recommending based on their data that's being collected actively. And also the precision medicine therapy, right, to improve disease, treat disease and improve patient life. Prognostics and diagnostics, those are two key main markets for these Internet of Medical Things technology, right? We have lots and lots of potential there. So this is something that is a huge market, that's coming up. And we can look at this from a time versus technology reach perspective. And if you look at that, on in somewhere in 2008 and 2005, we have the RFIDs bands for locating people. But now that went on to personal biosensing devices for fitness, like by Fitbit and several other things, right? That's mainly because of miniaturization of the technologies, right? We are able to cram too many things into a small system, right? And in 2020s, we are now converging towards the geolocation of health applications and how the infectious diseases are spreading. That reminds me of one of the project in Ohio State University that tries to track how the diseases spread through phylogenetic trees using the airline data and things like that. That's something that we can now track so many other diseases which were previously we were not able to track efficiently, right? So that is something that is the technology is reaching out, right? And medicine at distance and so many other things that are coming up, telepresence, remote examination, as well as surgery, right? There were so many other technology improvements in surgery. So all in all, we see that why this data science is going to be a booming industry, right? There are so many reasons, mainly due to technological advancement. So what is data science? What is data science? Have you thought about it? Any of you here? I mean, I don't want to be this to be a monologue, okay? I want a very interactive classroom.
Just like
how you are interacting with data. What does it mean?
the study of how you can interact
Can you give me an example?
For example, if you're analyzing data
Mm-hmm.
to see trends over a 10-year period,
Mm-hmm.
how would you go about, when I think of the science of that, how would you go about looking at that trend
Okay.
handling the data?
Right. Yeah, that's mean a sort of a predictive analytics. Okay. Any other answers?
I guess it's like, that's similar. Finding new relationships based on a lot of information. So making those connections. I know, like they were able to diagnose someone with actually domestic abuse based on like a bunch of her hospital visits
Mm-hmm.
using like data science. Like she had come in for like UTIs, all these random things, and through that they were actually able to find that she was actually being domestically abused. I saw a TED talk on it.
Mm-hmm. Mm-hmm. Sure. Sure. So, okay, let me define this question. You all know statistics, right? Or at least the power of statistics, right? It's used in modeling. How many of you heard of regression? Almost all of you. Okay. You can predict using regression, right? Trend lines. So how is it different? Data science is different from statistics.
Okay, I have an idea probably that data science is a pretty broad term itself, so it's probably not just any particular thing with statistics, but collection of tools that you employ to treat data, to use some predictive algorithms and so on and so on.
Right. Yeah, this is exactly what data science is. Actually, it's a very, very generic term in the sense that, the book that we are going to follow that says that data science is a state of mind. I think that's a fair definition for data science. It is not a particular way of analyzing data. It's just trying to find meanings in the data using whatever information or tools that we have at hand. Okay, it could involve math and theory. It could involve statistics, optimization, linear algebra, and it could involve computer science, algorithms, machine learning, right? I mean, data structures. So probably one may have to come up with a new data structure. So what are the basic data structures? Computer science people? Trees, linked lists, arrays, queues, heap. So there are lots of data structures. It's a smart way of arranging data. Okay, so it's nothing fancy about it. But it could be, you may want to do something with a, make a new database, data structure to find pattern in it. That could perfectly fit under the scheme of doing data science. And storage, it could involve engineering and technologies, right? Storage, computing platforms, uh, coming up with, say, quantum computing. I would say that that's also probably a part of, using the quantum bits to come up with doing data science. And domain expertise takes finance, images, things from econometrics, and art, actually. I could remember in Texas A&M there was the College of Architecture, right? They had a very novel way of visualizing things in a 3 dimensions, like integrating art with the data. So that is something that's a very novel way of looking at things. Like there is something called Hilbert curves. Like, how do we visualize? I mean, we humans are visual creatures, right? So we need something concrete to visualize. So that's another fascinating area of visualization through art and infographics, right? I mean, if you have an infographic, you'll be able to understand much easily than having a laborious text of 1,000 words, right? So how do we come up with that? So that's a very critical part of doing data science, and also best practices and hacks, right? I mean, actually, I would say that hacking constitute one of the major aspects of doing data science. And before going into that, let me give an example of data science in healthcare, survival analysis, right? It's analyzing the survival statistics for patients with different attributes and treatments. Or dosage effectiveness, we can study the dosage based on a medication for a disease, right? Or readmission risk, which depends on diagnosis, treatments, and patient attributes. So, I mean, this is some of the examples of doing data science. But in general, one of the key things, I would say that this is not a representative definition for data science, because there is no consensus on what is data science unless it's a very broad. I mean, we say that it's some things that leads us to the insights in the data, right? Conway came up with a definition saying that we need hacking skills, math, statistics knowledge, and substantive expertise. And data science is in the intersection of these things. I would say that hacking skills are more important, actually. Like a simple skill could be when you see a website, right? Just remove the last few entries in the address and see what's there in the parent directory, right? That's a very 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 elementary hacking skill that one may have, right? That's one of the key things to have is hacking skills. Like, try to get whatever we can hold off to see patterns in the data. If some tool is good, just use that to identify and mine patterns in the data. But Steve Zeringer, he came up with a different definition of data science, in which we had data science encompasses all of things: computer science, machine learning, math, statistics, subject matter expertise, and everything together. And in between this unicorn, there's nothing we know about how the intersection looks like. So, I mean, these are matters of nuances in refining what data science is, right? I mean, it's embedded in our psychology to categorize and classify things and make it more concrete. But in general, if we look at how the real world experience tells us that things are not concrete all the way, right? There are gray boundaries everywhere. So we need, even though we don't have an exact definition of data science, but we all know what is data science, and that is far more important than sticking to some definitions of what is it and what is not that. Whatever works, right? Even evolution just works, right? It doesn't try to optimize based on a scale, right? I mean, whatever works, it's using. So that's what the whole philosophy behind data science is chasing directed insights, right? Rather than sticking to definitions. And honestly, in this course, we will be doing more of doing data science than I said, exploring what data science is about, right? So if you look at the key paradigm, according to the book R for data science, so the paradigm is explore, wrangle, program, model, and communicate. So this is what we will be doing throughout the course. We will be following this definition of doing data science. We would be exploring, which means that we may have to transform and visualize the data, right? These are the key things that we always do with the data. We import the data. Once we import the data, the real world data is generally so messy that we need to tidy up. And then we have to transform the data, visualize it, model it. And this is an iteration that we keep on doing all the time, right? And then later communicate. So this is the paradigm that we will be exploring the data, and there are tools for exploration. And wrangling the data means that we import, tidy, and transform the data. And program, which encompasses all. Here, communicate means that we will be communicating through writing a good documentation for what we did. So that is that is why program also encompasses communication, and we have a model. We also have to model it, right? It's a very iterative process, as I told you. We have to model the data, and then for communication and visualization, they go together. So we will be doing all this with an emphasis on communication. So that's the key thing that we are going to focus on. This course would start with communication. So in the book R for data science, if you look at it, the book starts with explore, wrangle, program, model, and communicate. But we would be first focusing on communication, and then explore, wrangle, program, and model. That's the thing that we are going, because communication of the data is critical. Like, you will do some analysis now, and after 6 months you will see that you will not remember what you have done. So it's very critical to have a documentation and communication of the analysis. So that's the focus of this course is going to be. So what is a data scientist, right? I mean, we looked at what is data science. So data scientist should have an amalgamation of skills. He or she should have math and statistics background, right? I mean, all machine learning, statistical modeling, mathematical modeling, and programming and database skills. That's critical. We will have a lecture series on databases in this course. We will be seeing the Postgres and SQL queries, and he or she should have the domain knowledge and soft skills to do this, as well as communication and visualization. So these are the 4 key aspects. And this is a cool Venn diagram that I came across about who's a perfect data scientist. So I thought this was neat. If you just know statistics, you're just going to be a data nerd. And there is a difference between an analyst and a data scientist. So this data analyst, right? The types of data are going to be structured and semi-structured, mostly numeric data. And whereas the data scientist, they work with all kinds of data, whether it's unstructured or structured, with preferred tools of using R, Python, machine learning, and language processing, right? If you look at the nature of the work, it's exploring, discovering, and investigating wherever the results lead to, right? I mean, it does not depend on any specific set of hypotheses which analysts typically focus on, right? They predict and prescribe and optimize. And whereas the typical educational background is computer science, data science, and symbolic systems for data scientists, whereas analysts generally tend to focus on operations, research, and statistics. Although, I mean, these demarcations are not set in stone, as I said, but in general gives an idea of the difference between a data analyst and a data scientist. Roles and paychecks. There are several roles. I looked up on it and I saw that there was advertisements for data engineer, for database administrator, there was business analyst, and the data scientist. And I was trying to look at the difference, and this is what I came up with. And also, actually, there was a Nature article that was published just 2-3 days back that discussed some of these roles where they emphasized knowing the difference between these things are important, where they said data engineer focuses on mostly the robustness of data, whereas the database administrator obviously focuses on the databases are set right and the data is available. And the business analyst usually works with hypotheses and predictions based on statistical modeling, whereas data scientists or they perform the varying types of tasks, right? I mean, they could do distributed computing, predictive modeling, and in general analysis. So the salaries are accordingly distributed, with data scientists earning much higher than the rest of the people. So about this course, this is going to be more of practice than theory. We are not going to focus on theory. Okay, this is going to be a very basic course. It's going to be introductory, but it's not going to be elementary. Okay, so this is designed with biology and medical majors in mind. So if you're already good in programming and you find some of these exercises to be elementary, I mean, you can't really help it. So the theory is said to be going to be a bare minimum. So only in the context of programming there is going to be a theory, and we are going to focus on practical aspects, which means that programming. Okay, so we are going to use advancement in technologies. Our studio is like evolving almost every day, so we are going to use our studio, and the emphasis is on communication, reproducibility, and version control. I mean, that communication also means communicating in the class. Okay, so I want more interactions in the class, and we will talk about how to. But then there will also going to be a hands-on. This class I want it to be a more hands-on than just me lecturing. Okay, so we are going to go over some of the exercises which we are going to go do together. And suppose if the class time extends, you are going to practice that. I'm making this all available, so it should be easy for you to follow on. And we will also be working with databases. There's going to be 3 courses, that is 3 lectures that's going to be with the databases, and we are going to work with a biomedical and population health data set. Okay, so that's what we are going to do. So why we have chosen R, not Python? I mean, Python is a more full-fledged programming language than R is a functional language, which is very powerful. So if you look at the the distribution of the skills and paychecks, R stands out to be one of the very high-paying jobs, as well as we will see that it has very powerful packages for manipulating so many things. So the first few lectures are going to be basics R. We are not going to go any detail into doing any kind of anything data science oriented. But once you have your own set of repositories, which we will talk about now, then we will start focusing on the data science aspect. Okay, so what you are encouraged to know, but it's not essential, is that data is usually represented as a matrix. Okay, that matrix could be of same, all the entries could be of same data type, or otherwise they need not, right? R has a special name for the matrices that don't have a same data type. Do you know what it is? It's called a data frame. Okay, so we will study all these things, but in general there is a difference between matrix and a data frame. A little linear algebra will go a long way. Okay, so mathematics is good, it's not essential, but if you want to end up in a very high paying career, then probably math and statistics skills are important. So you may want to attend my linear algebra lecture on 27th. Okay, so I'm going to talk about some basics of linear algebra. In data science, most problems are vague, so that would involve you to come up with questions and answers by yourself. Okay, some of the assignments are going to be like that. So probability, statistics, and machine learning are very important. I mean, for not for this course. These are not essential for this course because this course is going to be very, very basic. But in general, if you want to do a good data science career out there, then probability, statistics, and machine learning is very important. And fundamental concepts in algorithms and data structures. Very good to know. It's important. And I'm teaching a algorithms lecture on September 25th. Okay, usually algorithms is a course, it's a core course in computer science. It's a semester long course, but I'm going to cram it in one lecture. So imagine the difficulty it's going to. It's going to be very basics. It will give you a very generic idea on what algorithms are and how to analyze algorithms. So so fundamental concepts in algorithms. There are good books. So if you want to know about some good books for reading this, for reading any of these materials, let me know. I'll be happy to let you know about these things. And high performance computing. We have a very good facility here in HPC. Who all has HPC account here? Okay, good. So it's good to know cluster computing, how to distribute your jobs. But as I said, this is all encouragements. I mean, these are all encouraged than what's required for the course. We are not going to do any HPC or anything over the cluster computer in this course. And genomics and epigenetics. Again, these are going to be integrated with the big data as we progress. So it's good to know some genomics, but it's not essential. Textbooks are for data science. This is a very good book. This has been prescribed in several data science classes and courses. So this is a free book that is available. The PDF copy is available out there. So all we are going to heavily focus on this, the paradigm that's being promoted in this book, and also R in action that gives you a basics of R. So these are two important textbooks for this course. If you want other data science books, there is a very good book by these four. It's called An Introduction to Statistical Learning with Applications in R. It's a Springer book. It's a very good book for statistical learning and inference. And also visualization. For visualization, ggplot2. We will be covering ggplots in some detail in this course, but this book is an excellent book for visualization. Okay, let's rock and roll. Sign-in sheet. I think we are done here. Registered versus non-registered students. I mean, from the context of the course, it's going to be the same. But for grading, I'm not really sure. I am trying to find a TA. So it would depend on that. But you are encouraged to work on the assignments and fix up any appointment with me to talk about it. So I'll be happy to do that. GitHub registration. Okay, who knows about Git here? You all have Git accounts. That's great. Okay, so that is something that I wanted to do at the start. And there is already a homework being assigned. That's a simple homework for people who know Git. But for the course, I wanted to get everybody into one stream. So this is the web page. Okay, I can send you this by email again. I think I sent this to you by email, but if I'm going to send you another email, maybe in the next couple of days, I will include that. Okay, so this website is why I don't see the website here. It's crazy. This works. Oh, I think I have to mirror my screen or something. Okay, so this is the official course for this official page for this course, and you have all the information here. The office hours are between 2:30 and 4, and through appointment, you're encouraged to come to my office hours and fix up appointment, and talk to me about anything that you are having trouble with during the course. The course information, and we are going to meet in this room except for September 28th, 29th, and October 26th. These 3 days. Oh, I don't think it's 28 and 29. It's always Tuesdays and Thursdays. Maybe 27th, 26th. Yeah, 26th and 28th. Yeah, I'll change that. And all the learning objectives, course overview, policies, course assignment, everything is here. So the book, the recommended reading book, it's here. So you can choose. Not able to see this in here. So there is a PDF there. If you click on it, it will take you to the web page in the book. There the book is listed. Okay, so introduction. So today's, I have a link here. If you click on this link, you will have the PDF of the presentations, the presentation that I just made. So the first thing is you need to register into a GitHub. Okay, so I'm going to keep on asking you even next week when you will have, you will have to get this Git out. Everything has to be done in Git. So that's the thing that we are going to do for this course. And there is also a student developer pack for Git. You are encouraged to apply for that. Okay. And there is a discussion page in GitHub. I made a discussion page. So if there are any issues, you're welcome to raise an issue. Go there and click a new issue, and then ask that question. And also, don't freak out if you are having problems. I know that there are people who already have programming and GitHub experience, but don't freak out. Come to my office hours and talk to me or ask for help. Okay, so I'm pretty much I'm here almost all day here. So I'm on the 7th floor on 738. Okay, so R and R Studio. The first thing is you need to install R and R Studio. Do you all have R and R Studio? Who doesn't have R Studio? Okay, so that's what you need to do. You can go ahead and start installing that. I would encourage you to install the latest version. Even if you're having the previous version, install the new version on top of it. Okay, and once you open the R Studio, you should see something like this. Who has not seen the R Studio? This is the console and the history. This is a console editor, history, and the plots and everything that you see here. So this is a thing that you have. So everything is here. So if you go to my page, in this page, you will see what needs to be done for installing, where you need to go and install, and how to add packages. Once you install RStudio, you can go to the console package. So here. So once you install RStudio, you can go to console here and then type in install.packages, whatever packages that needs to be installed. We will go over that in detail. I mean, as we go through the course, there will be packages to install. So anyway, we will be doing that. And there are excellent resources and support for R. It's one of the very popular languages. I'm sure there will be tons of tutorials you might have seen in YouTube and Coursera and edX, and there are lots and lots of learning tutorials for there. So for learning R, and you have to learn Git. Okay, so this course, how many of you have used terminal in your computer? Okay, so get friendly with your terminal. Okay, so that's very important. Whether you mean the big data, everything is handled through Unix. So it's you have for terminal. Those of you who are having Mac, the terminal is in applications. If you go to applications and utilities, there'll be a terminal button. Okay, so if you click on that, you'll and get a terminal. And there you can go to this GitHub tutorial for beginners. There are so many GitHub tutorials. I have posted a couple of them here. You can practice Git through the tutorials. Okay, so that's something you may want to do initially, the first. I mean, okay, so that's something. Even if after this lecture, if you want to sit and do Git, you should. I mean, you should be able to start working on it. So we will work with RStudio, Git, and GitHub throughout this course. Okay, so that's what we are going to do. But there is another excellent resources here for learning, for integrating these. It's Happy Git and GitHub for user R. Okay, so this is our very nice section for how to integrate. The RStudio already has integrated GitHub in there. So this is about how to make it synchronize and work with both of them. So it's a very nice resource for it. Okay, and I have listed lots of selected materials and references for this. So feel free to go through all of these. So that's for today. I mean, I think I don't want to overwhelm you with lots of stuffs. In the next class, we will go over basics. Okay, you should all have RStudio installed and first install R and then RStudio, and then for the next class we will be going over the basics of R. The next two classes, which is next Tuesday and next Thursday, we will be going over the very basics of R, and then we will go on the R markdown, communicate, and then doing data science later on. Okay, so those who are already familiar with lots of things, you can try out this homework. It's just editing the README file through GitHub, so it's pretty easy. But before that, I mean, I would want you to send me an email with your latest information. Oh yes, I want the email that you register with Git, right? I want the email address that you use for registering with Git. That is very important for me, because as soon as I assign the homework, I'm going to send it through your email, where you will accept, in logging into your Git account, you will accept my homework. So I need your email. Otherwise, I will not be able to grade your homeworks and you will not be able to pass. So that is very important for me. So for this class, so send me your email. Those who haven't sent a response to my earlier email, I would suggest you to do that. Okay. So yes, so I think we will sign off for today now. But who wants to work with installation, R installation and R, I'm going to be here helping them out. Yeah. Questions? Yeah.
If you want us to do, they had like a summer pre-release that was new. Do you want us to download that or the one before that?
Download the stable version, whatever the stable version is. So they have a summer, they should.
It said like summer pre-release. That was like the latest.
R or RStudio?
No, just the R.
Oh, just R?
The developers page, yeah. So
Oh, yeah. I think it's fair to download the R version 3.4.2, the latest one. It doesn't matter. I mean, most of the stuff that we are going to do, I think it's version 3.3 or later, I think. So I think it should be fine. Yeah. Any question? No? Okay. So I think you can install R version 3.42. That should be fine. Who has Windows computer here? Okay. I think it should be the RStudio is there for Windows as well, right? So it should be fairly straightforward. It should not be too difficult. I don't think you need anything really that requires Mac or something, but I think it should be just fine. If you're having any troubles, let me know. Okay, I can. So if you are okay with so far, comfortable with things, you can sign off for today. But I'm going to be here helping people installing R and getting the basics set up. Okay, so GitHub. Don't forget GitHub registration and the email that you signed up for registering Git. Just send me those two information. Okay. Yeah.
your email. Can I get your email address so I could send you an email?
Oh, okay.
Thank you. Thank you.
Hi.
Hi.
Sorry. I was trying to connect to the internet the whole time we were talking, and it says that I've connected, but I am not connected.
Are you in Langma? I mean, I think you should.
I'm in GSS,
GSP.
graduate student
Oh.
of arts and science.
You should have it. You should be able to connect the LMC.
I tried, and it says that I've connected there, but then it tries to redirect me here, and then it says something about some kind of HTTP that it won't allow.
Oh.
So I don't know what to do because it says I'm connected, but I can't get to I can't even get to Gmail. So I can't.
Oh. Yeah. This is.
I'm sorry. I
You need to set certificates up. It's a Windows machine. You need to set certificate to connect to LMC Mobile.
Do you know how to do
Yeah.
that without Thank you. You're wonderful.
I've had to do it like this many times.
Oh, sorry.
So I don't know, but something like it's from some of the mirrors from that website.
Will this
So this is
this
our
automatically?
console, but it looks
In
like
future.
this.
Oh, thank you.
So
you see, you
does
need to
it
tell it what type
will
of
it be able
security.
to program now? Because I just did studio.
Yeah. So this is the studio should take. If you have already installed R, so
Okay.
you don't have to worry about it. You don't need. You can, this should be just fine.
Okay.
Yeah, that's a standalone
Will it
R
redirect me to the
environment.
user?
But RStudio integrates that, so the editor. This is the same as typing in there.
Yes.
You
So-
know how to do it. You're already
I know how to
like
do
10
it.
steps
Right.
ahead
Yeah,
of
you
me.
get this panel. You get an editor
Been, like,
panel.
switching off,
You know, you can go and have a default view. Show all panels.
So now I
So
have
Windows
to
10,
from those
like,
other links
if you have
that
Windows
said,
8, I could do this.
I've actually
download
had
packages
Windows 7, so
to
this is like
down here, so I have to install this package, so I have to type this command line.
No, you don't. This is in general for, yeah, well, you can install tidyverse. We will be using tidyverse, so go ahead and install tidyverse.
So I can
Yeah, you can just have,
copy.
yes, just copy and paste it in there. It should install.
I know it's a little bit. It's hard.
I'm Control C. Okay.
Yeah, control.
It's long since I used. Where is the RStudio? Yeah. Okay. So this is the console. Go here. Paste. Control P.
And no V.
Control P. Yeah. Okay.
Yeah, you can.
Yeah, it should technically install everything.
I was
Yeah.
looking at you the whole time. I was like,
So
what
it's
the hell
installed.
I wasn't sure, and I didn't want to be rude, but then I
No.
think I must have ended up looking at you.
Filters.
Yes, but your hair is like
When it will slow down. It's like it takes forever.
I'm
It should.